Okay, so we saw in the first video that we're going to learn several techniques, okay, a total of 5 techniques of being able to factor. Um, but one thing that will make your life a little bit easier is that you always want to attempt to at least see if there is a greatest common factor, okay, between the two terms or however many terms that you can factor out first, okay? And that will make the rest of your factoring a little bit easier, okay? So, like I said, factoring is like simplifying. Sometimes you start simplifying a fraction and then you realize you can simplify it a little bit more. So, sometimes it's a process where it takes a few times, a few attempts, a few different techniques to being able to factor completely. So, like 21, before we check to see if it's a difference of squares, let's go ahead and look and see if there's anything that I can factor out. Okay, a greatest common factor that I can factor out. And I noticed to myself that I can divide both of these by, can I divide them by? I can divide both of them by 2, right? Okay, I can divide both of them by 2. Now they don't share any common variables, so that will be all. So I'll pull out that 2, and what will I have left? I'll have an n squared minus, well, what's 72 divided by 2? Well, 70 divided by 2 is 35, so that's going to be 36. Okay, so what do I have left inside of my parentheses? I have an n squared minus 36. That looks like a difference of squares, right? You got 2 terms inside there with a subtraction. Now check and see, can they both be written as squares? Well, yeah. So first of all, make sure you always keep that 2 along for the ride, okay? It's got to stay there. We've got n squared minus 6 squared, okay? So whenever you go to factor, one thing that you want to make sure that you always remember is that 2, this 2 has to always, is still a factor. So it has to be expressed in the final answer. So it'll be 2 times my binomials that I'll create, right? The plus and the minus. My first term is n, plus my second term is 6, and then my first term n minus my second term 6. So when we factored this, we have it written as a multiplication problem, but it's written with 3 factors if you notice, okay? So whenever you factor an expression, sometimes there's going to be lots of factors, okay? All right, so let's look at 18. Is there anything you can divide evenly out of 18 and 50? Yes, I can divide, I believe, a 2 out, right? Because they're both even. So I have my 2, and then what's left? Well, 18 divided by 2 is 9, x squared, minus 50 divided by 2 is 25. Okay, this is really looking like we might be able to express these two values as squareds. 9x squared is the same thing as saying 3x squared. Okay, minus 25 is the same thing as saying 5 squared. If you notice, guys, I had to put this inside of a parentheses because my whole entire first term had to be a squared, okay? This parentheses had to stay intact though as well because this 2 is multiplying everything inside of it because we pulled that 2 out of it all, okay? So we will have that this is equal to, we got to keep our 2 out there, 2 times the quantity. So I'll have 2 sets of parentheses. My first term is 3x, plus my second term is 5. My first term is 3x, minus my second term is 5. Okay, so if you guys would like to check this, just distribute, okay? You take your binomials and you multiply each one by each one, and then after you're done with that, you'll have to distribute that 2 in as well, okay? So lots of multiplying to be able to check that answer. Okay, 23, right now, the way it's written, I don't know if this is a difference of squares, but if I check to see if there's something I can pull out first, I think we'll be in luck. So 32 and 18, what can you pull out of both? I believe I can pull out, let's see, I can pull out a 2, right? Again, that seems to be a common theme. All right, now, oh, I'll put those underneath like I always do. They don't have any common variables. Okay, so that will be it. So I'll pull out that 2. 32 divided by 2 is 16s squared minus 9u squared. Okay, now it's going to be important that my terms inside of here are written as squares. Okay, so maybe I'll do a little color coding. The first one is, what's my first one going to be? 4s squared minus, what's my second one? My second one's going to be 3u squared. Okay, so sometimes colors can help us keep track of all that. Okay, so this is going to be the same thing as saying 2 times the quantity. So since we have a differences of squares, I'm going to set up my parentheses. This is going to be a plus, that's going to be a minus. We have 4s plus 3u times 4s minus 3u. Okay, and so why are we doing this? Okay, why are we writing this as, why do we care about writing these simplified expressions as in its factored form? Well, we're going to see in our next unit that solving equations that are not linear equations, solving equations that have exponents like x to the second, okay, when we try and solve those equations, we won't be able to solve them unless we're able to, one technique would be to factor, okay? So we'll see this technique being used later for solving equations. But for right now, I just want us to practice factoring, okay? All right. 24. Is there anything you can divide evenly out of 45 q cubed and 20 cubed? Well, I'm looking at my coefficients and it looks like I can divide a 5 into both. And then this guy has 3 cubes and this guy has a cube. So if we pull, we can pull out maximum of 1 cubed, okay? 1 q. So I'll pull out the 5q. And what do we have left? We're going to have 9q squared minus 4. Well, I'm pretty sure that I can write these two terms as squareds. So 9q squared is the same thing as saying the quantity 3q squared minus 2 squared. Okay, so my terms inside are in fact the difference of squares. So I'll still have my 5q. Do not forget that. Okay, times, okay, we've got 1 and 2. So we've got my first term is 3q plus my second term is 2, and then 3q minus 2. Okay, so I'm going to go ahead and let's see how many more there are. Oh, let me clear this all away. Oh. Okay, so I'm going to let you guys do 25, 25, 26, 27, and 28. Okay, don't forget to make sure that you are factoring out. Okay, we're factoring out the greatest common factor first. All right, so let's go ahead and do 29. So 36 and 9, so I can pull out a 9 and I can pull out a p. So I have 9p, and what do I have left? 36 divided by 9 leaves me 4p squared minus 9p divided by 9p is 1. Okay, be careful with that. Okay, we can't just cancel it out and have nothing left. We always have a factor of 1 at the very least. Okay, so this is going to be 9p times the quantity. Well, this is the same thing as saying 4p, or sorry, same thing as saying 2p squared minus 1 squared. So what will we have at the end? 9p times, I'll set up both of my parentheses, the first term plus the second term, the first term minus the second term. 2p plus 1, 2p minus 1, okay? Looking here, let's see, the only thing I could divide out of my first term is 3. 147 divided by 3. Let's see what that is. 3 goes into 14 4 times. 4 times 3 is 12, 27. 3 goes in there 9 times. Okay, so I can pull out a 3 from both of these. So I have 3 times the quantity n squared minus 49. So I'm going to go ahead and verify that I do have a differences of squares by rewriting 49 as 7 squared. Okay, and now that I have my difference of squares, I'm going to factor. So I still have my 3, and then I have n plus 7 times n minus 7. Okay, I'm going to let you guys do number 31. All right, and I'll do 32. So I look and see, it looks like I can factor out an m and an n, an m and an n. So I'll pull those out. I'm left with m squared minus 1. Okay, now this is pretty easy to make sure that these terms are both squared. M squared minus, well, 1 is the same thing as saying 1 squared. So I'll just not copy it back down and write that squared. So I'll have the mn out front and then factor it into 2 terms, a minus and a subtraction, right? So the first term is m plus 1 and then m minus 1. Okay, and then this is an m. Oops, an m. Okay, so if you guys have any questions on this technique, just come see me on Zoom.